Hello, good evening, students. Very good evening to all of you. Am I audible and visible? Please confirm me audibility and visibility. Okay. चलिए start करते हैं. Welcome back to PW platform crash course in algorithms. So in the last class we were talking about greedy method. हमने greedy method देखा, procedure देखा, control abstraction, and we have also solved one problem of knapsack wherein I have shown you how greedy different approaches. Yeah, good evening Neha Mishra. What can be the different approaches for solving a problem based on greedy method for knapsack problem? Greedy, you can be greedy about profit, you can be greedy about weight, and then you can be greedy about profit per unit weight. Then we saw that the third strategy, greedy about profit per unit weight, is supposed to be the ideal strategy. Yeah, very good evening to all of you again. Once again, welcome back to PW platform. आज का हमारा एजेंडा है continuing with greedy method. We will look into one graph based problem which is called shortest path problem, single source shortest paths. Popularly जिसे हम बोलते हैं Dijkstras algorithm. In the commercial market or in the industry, people generally call it as Dijkstras algorithm. आपने computer networks में भी जब routing algorithms पढ़ते हैं, right? Routing algorithms. वहाँ पर भी shortest path routing जब बोल के हैं, we generally adopt or follow this Dijkstras algorithm. Yeah, Shofir Khadir, we will see if time permits, we will work out a problem on job sequencing with deadlines and a couple of problems on spanning trees. Issue is the time. This is a crash course. We can't, even if I want, I can't take up all the problems. So essentially जो भी important है हम discuss कर रहे हैं यहाँ पर, ठीक है? जो भी important problems है. One problem we'll try to see on job sequencing with deadlines if time permits. लेकिन ये बहुत important problem है from my examination perspective. Therefore, I feel like we should discuss this problem first. Single source shortest path. Start करने से पहले मैं ये बताना चाह रहा हूँ कि आपको first we will have a general discussion on shortest paths problem of shortest paths in a graph. जब हम shortest path problem की बात करते हैं, what are the different types of shortest path problem we have? Can you just write down? I'm not asking algorithms, I'm asking names of the shortest path problem. What are the various shortest paths problem that are there in the literature of algorithms? Names of shortest paths. कौन से shortest paths है? Like one, अभी जो हमने देखा single source shortest path, उसी तरह और कौन से shortest path problems है? Single source and all pairs. दो ही है, सत्यम? Are these the only two? I would say first, in a trivial sense, we have single pair shortest path. Single pair shortest path. Single pair shortest path का मतलब ये है, yeah. Neha Mishra, it is not Wellman-Ford, it is Bellman-Ford. I will talk about it. Prim's, Dijkstra, Kruskal, Prem Kumar. Prim's and Kruskal's is not for shortest path, that is for basically minimum cost spanning tree. दोनों problems अलग है. So let us have a clarity on this. Generally people get confused, or मैंने पिछले get questions में देखा है, they will also make a mention like name of the problem and what is the algorithm and what kind of problem it solves. ये भी आपको clarity होना चाहिए. Single pair shortest path. तो ये problem है to find shortest path between one source and one destination. That's it. Single pair. One source and one destination. Yes. Second is single source, जैसा हमने यहाँ पे अभी कहा, single source shortest paths. Single source shortest paths. यहाँ पे plural है paths. Yeah, Rahul Kumar, you're right. Floyd Warshall is also an algorithm. So single source shortest paths मतलब we are given a one source vertex and you want to find shortest path to all the remaining n-1 destinations. Destination 1, destination 2, so on, destination n. Remaining n-1, assuming there are n vertices. This is called single source shortest paths, right? Single source shortest paths. अभी यहाँ पर एक चीज, before I proceed, I would like to tell you that there are two algorithms for solving this problem. There are two algorithms for solving this problem. जैसे हमने कहा, one is Dijkstra's algorithm. Dijkstra's algorithm. This taxonomy भी बहुत important है, बाज़ वक्त गेट एग्जाम में they ask this question, so that's why I'm putting the whole taxonomy at one place. Dijkstra's algorithm. The other algorithm is called Bellman-Ford. Bellman-Ford. Dijkstra's algorithm is purely based on greedy method. It's a greedy strategy. Whereas Bellman-Ford, can anybody tell me, Bellman-Ford is based on which algorithm design strategy? Is it also greedy or is it any other strategy? It's also an important question. Sometimes questions are asked like that. Bellman-Ford algorithm, also used for solving shortest path problem, single source shortest path, is based on not greedy method but dynamic programming. Based on dynamic programming. Second important characteristic that you have to remember, that you have to conceptualize, is that Dijkstra's algorithm will work only with positive weight edges. Positive weight edges. मतलब ग्राफ में अगर आपके पूरे पॉजिटिव वेट एडजस्ट हों तभी Dijkstra's algorithm would work out always correctly. Would always work out correctly. But just in case if the graph has negativity, negative weight edges, please follow my point. क्या बता रहा हूं मैं कि in case if you have negative weight edges in the graph, then Dijkstra's algorithm may not work. I am not saying will not work, may not work. May not work. Right? So if in case if the graph has negative weight edges, Dijkstra's algorithm sometime may work for some special cases of paths and special cases of vertices and edges, and sometimes it may not work. But Bellman-Ford algorithm can always work with negative weight edges, provided there is no negative weight cycle. ये बहुत इंपॉर्टेंट पॉइंट है. शायद आप कुछ लोगों को या आपको पता हो या ना हो व्हाट इज नेगेटिव वेट साइकिल, पॉजिटिव वेट साइकिल. मैं अभी थोड़ी देर में आपको एक एग्जांपल लेके बताऊंगा कि व्हाट इज पॉजिटिव वेट साइकिल, नेगेटिव वेट साइकिल, और क्यों नेगेटिव वेट साइकिल के लिए कोई एल्गोरिथम वर्क नहीं कर सकता, वो भी हम देखेंगे बिफोर वी कंटिन्यू विद Dijkstra's एल्गोरिथम. हमारा मेन एजेंडा है Dijkstra's एल्गोरिथम, लेकिन पॉजिटिव वेट और नेगेटिव वेट एडजस्ट और पॉजिटिव वेट साइकिल, नेगेटिव वेट साइकिल के बारे में भी थोड़ा हम डिस्कस कर लेंगे, so that such questions which were asked earlier and in case if they are further asked you should not have any problem. ठीक है? तो नो नेगेटिव वेट साइकिल. अगर नेगेटिव वेट साइकिल हो अगर ग्राफ में, तो माय डियर स्टूडेंट्स प्लीज रिमेंबर नो एल्गोरिथम कैन वर्क. व्हाई? आई विल शो यू शॉर्टली व्हाई इट कैन नॉट वर्क. ठीक है? दैट इज सेकंड पॉइंट you have to remember. So I'm hopeful you have understood this taxonomy so far. There are two algorithms for single source shortest paths problem. One is Dijkstra's algorithm based on greedy method, and that can work always correctly in case if the graph has positive weight edges. If the graph has negative weight edges, Dijkstra's greedy algorithm may or may not work. But Bellman-Ford algorithm based on dynamic programming can always work in case if the graph has negative weight edges, but no negative weight cycle. No negative weight cycle. No negative weight cycle. Yes. In case, last point I am saying, in case if the graph has negative weight cycle, no algorithm can work. That's it. This you have to remember. Then last point I would like to tell you, we have another shortest path problem. The last shortest path problem we say, all pairs shortest paths. All pairs shortest paths. All pairs shortest paths. Right? So the algorithm which is used for solving this problem is called, as people have mentioned, Floyd-Warshall's algorithm. Floyd-Warshall's algorithm. And Floyd-Warshall's algorithm is based on dynamic programming. Based on dynamic programming. लेकिन यहां पर एक क्वेश्चन ये है, ऑफ कोर्स द मेन ट्रेडिशनल एल्गोरिथम फॉर सॉल्विंग ऑल पेयर शॉर्टेस्ट पाथ प्रॉब्लम इज फ्लॉयड-वार्शल्स एल्गोरिथम व्हिच इज बेस्ड ऑन डायनामिक प्रोग्रामिंग, ठीक है। लेकिन क्वेश्चन इज व्हाट इज ऑल पेयर शॉर्टेस्ट पाथ फर्स्ट। सेकंड क्वेश्चन, कैन वी सॉल्व ऑल पेयर शॉर्टेस्ट पाथ प्रॉब्लम यूजिंग ग्रीडी मेथड? दिस इज माय क्वेश्चन। तो पॉइंट नंबर 1, ऑल पेयर शॉर्टेस्ट पाथ जैसा बता रहा है, नेम बता रहा है कि वी वांट टू फाइंड शॉर्टेस्ट पाथ between all pairs of vertices, every pair of vertex, 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to n, 2 to 1, 2 to 3, 2 to 4, 2 to 5, 2 to n, 3 to 1, 3 to 4, all vertices. कोई भी pair of vertex आप ले लें, we want to find the shortest path. Yes? So this is all pair shortest path. So my question is, can we solve, this is my question, can we solve all pair shortest path problem also using greedy method? If so, how? कैसे करेंगे? क्या कोई कमेंट में लिख के बताएगा? How can you solve all pair shortest path problem using greedy method? डायनामिक प्रोग्रामिंग से ये बेसिस पर ये एल्गोरिथम है, फ्लॉयड-वार्शल्स एल्गोरिथम। लेकिन या प्रशांत, गुड इवनिंग, कैन वी सॉल्व इट यूजिंग greedy method? If so, how? Shifu Khadir is saying no, you cannot solve. Earlier Neha said you can solve. Neha, please tell, how can you solve? Can we solve all pair shortest path problem using greedy based algorithm or greedy based strategy? If so, how? Such questions are important from GATE exam perspective and also conceptually. We can't solve it by greedy method, okay? You can't solve. Yes, GATE Easy has told Neha Mishra, yes. Boss, time. I'm not asking about time complexity. My question is only one thing, can it be solved or not? See, when let us say, okay, if you are taking that way positive and negative weightages, I would say only if you have positive weightages, all pair shortest paths. If you have positive weightages, Prem Kumar, it is not critical. Yes, logical learner, you are right. If you have all positive weightages, let us say, like then can we solve it? Yes, we can solve it. How? By applying Dijkstras algorithm n times, changing every time the source vertex. First time you apply from source 1, next time you apply source 2, next time you apply source 3, and then like that you can do. So that way you can solve, assuming positive weightages. Of course, negative weightages raha to aap Dijkstras greedy cannot apply at all. I mean, we may work or may not work, we say. So therefore, in case if the graph has positive weightages, then definitely you can solve it using Dijkstras single source shortest path by applying n times, every time changing the source vertex. So complexity will become n into whatever the time complexity of single source shortest path Dijkstras algorithm. Agar Dijkstras algorithm ki complexity n square hai, so then it will become n cube with this approach. If it is n log n, then it will become n square log n, something like that. Okay? So that is the ideology of the shortest path. This is the taxonomy, this is the classification. You have to remember, single pair shortest path problem we say is a trivial problem. Because अगर आप ये प्रॉब्लम सॉल्व कर रहे हो सिंगल सोर्स शॉर्टेस्ट पाथ्स या ऑल पेयर शॉर्टेस्ट पाथ्स, देन योर सिंगल पेयर शॉर्टेस्ट पाथ प्रॉब्लम इज ऑलरेडी सॉल्व्ड, तो सॉल्व हो गया। दैट्स व्हाई वी से इट्स अ ट्रिवियल प्रॉब्लम। लेकिन यहां पर एक बात मैं आपको बताता चलूं कि एक पर्टिकुलर प्रॉब्लम है डायनेमिक प्रोग्रामिंग का, वो ग्राफ रिलेटेड प्रॉब्लम है, शॉर्टेस्ट पाथ का प्रॉब्लम है, दैट इज सिंगल पेयर शॉर्टेस्ट पाथ। कैन एनीबडी टेल मी what is that single pair shortest path problem of dynamic programming known as of graphs? The problem related to shortest path. So what is that problem of dynamic programming which is single pair shortest path? What is that problem? Exactly correct, Satyam. It is multi-stage graph. Multi-stage graph is a single pair shortest path problem. Okay? That we will see when we take up dynamic programming later point of time. So I was telling that predominantly, more importantly from examination perspective, आपको ये बहुत अच्छी तरीके से remember करना है और ये problem दोनों, single source shortest paths and all pairs shortest paths. दो algorithms है single source shortest paths के, एक है Dijkstra, can always work with positive weightages based on greedy method. Other is Bellman-Ford, can work with negative weightages. Dijkstra may or may not work, and that is based on dynamic programming. Lastly, एक है all pair shortest path, Floyd-Warshall's algorithm always work with dynamic programming approach. You can solve with greedy method also if graph has positive weight. अब हम देखेंगे यहाँ पर कि I take a simple example to prove my fact that y, I will take a simple graph like this. To prove why negativity or negative weight edges, we may not be able to find the shortest path. Those of you who do not know can have a look at this. I'm taking this example from the textbook of Gorman, please. It's a very simple example. Consider this graph. It's a directed weighted graph. Let us take some weights. 3, 5, 2, and this is -4. 6 and -3, and this is 3 and -6. Something like this. So if you observe this graph carefully, if you take S as the source vertex and G as the destination or whatever, because we want to find single source shortest path, you come to vertex A. There is only one incoming edge, so I can definitely say that the shortest path value to vertex A from S is 3, because there is no other incoming edges. Like that, even if this is negativity, this is negative -4, so therefore this value will be -1. Final value, shortest path value, shortest cost path to vertex D from S will always be -1, because there is only one incoming edge. So ऐसे cases में Dijkstra algorithm would also work. I am very sure you understand this point. In this case, Dijkstra algorithm, if you apply, it will work for such case, but may not work for other cases, right? For this case, it may work. Now, when I take -1, -1 plus 4, it becomes 3. So I would say that this is my first discovery to vertex G with a cost value of 3. I don't know it is shortest or not, but I am very sure these are the shortest. But for this may or may not, because I have two other paths. I have to explore them. So when I take up the second segment here, this cost is 5. So I may say that momentarily the shortest path to vertex B may be 5, but I don't know. It may be 5 or it may be, because I have another incoming edge. So I have to explore that. So I can discover a path to vertex E as 11, 5 plus 6, 11. But E, there is a loop here. So I can have, this is what is called as a loop or a cycle. The weight of this cycle is +3, positive weight cycle. So if I add 11 minus 3, it becomes 8. And 8 is definitely more than 5. So I say that definitely earlier value discovered itself is better, 5, because 8 is not. Now when I take 8, for example, so I can write it like this. The first path that I discovered to vertex B, S to B, is having a cost value of, let us say, or I will write like this, SB, right? Having a cost value of 5. And SBE, the path which I discover for this, is having a cost value of 11. Using the path, look at that, SBE, again B, SBEB. So that cost will be definitely 8. 8 is more than 5, so I can take 5 itself as better, right? And then this will become like 8 plus 6, 14. So 11 plus 3, 14. 14 is not better, right? So I put a cross. Then 14 plus 8 plus 3, next time it will become 11. 11 is not better, so I can take. And like that, if you see, the first path that you discover will always be shorter. So this is shortest, 5 and 11. So यहाँ पर हम क्या conclude कर रहे हैं? ये conclude कर रहे हैं कि in case if the graph has positive weight cycle reachable from source, then shortest path to the vertices in the cycle are always determinable or always possible. मतलब जो भी vertices positive weight cycle में होंगे, हम उनके लिए shortest path determine कर सकते हैं. Shortest path is always possible. This is the proof. So 5 and 11 are the shortest values. Remaining जो होंगे, that will always be more than 3 by factor. 5 plus 3, 8, 8 plus 3, 11, 11 plus 3, 14. यहाँ पर 11 plus 3, 14, 14 plus 3, 17, like that. So first values that are discovered are the shortest path. और अब देखेंगे 11 plus 8, 19 is not better than 3. हम छोड़ देंगे, ठीक है भाई, अभी यहाँ पे लेकिन when you come to the third segment, if you come to the third segment, the first path that I can reach SC here has a cost value of 2. With 2 plus 3, this become 5. To SCF, it become 5. Lekin from F we have an edge back to C in the form of a loop with cost value minus 6. So 5 minus 6 become minus 1, and minus 1 is less than 2. So I would put minus 1 is better path. Now with minus 1 plus 3 it become 2, right? And 2 is better than 5, so I change it. 2 is better than. Using 2 minus 6, it become minus 4. Minus 4 is better than minus 1, so I change it minus 4. Minus 4 plus 3, it become minus 1. Minus 1 is better than 2, so it become minus 1. तो इस तरह अगर आप करते जाएंगे, I mean if you take the loop and continue, every time that you discover a new value is always shorter than the previous. देखिए आप minus 4 is less than minus 1, minus 1 is less than 2, minus 1 is less than 2, 2 is less than 5. So every time you discover find a new value, it will always be decrementing by minus 3, and that is better than, superior than the previous value. Superior than previous value. तो इसका मतलब ये है कि you can never find, because of this loop, and the weight of this loop, the weight of this cycle is negative minus 3. So every new value that you discover will be less than minus 3 here and here. So therefore I say that the shortest path to this vertex will be minus infinity, means you cannot determine the shortest path to C. Likewise, minus infinity plus 3 will be minus infinity. You cannot determine shortest path to vertices E and F. Sorry, C and F. Minus infinity, minus infinity. So ये दो vertices are never reachable with shortest path from source. Hope you understand. And using minus infinity plus 7 will also become minus infinity. Minus infinity is less than 3, so therefore I update G also to minus infinity. इसका मतलब यह है, कमेंट अगर नोट आपके लिए लिख दूं मैं यहां पर, इस तरीके से हम लिखेंगे. In case if the graph has negative weight cycle, this was a great question, reachable from source is important. In case if the graph has negative weight cycle reachable from source, देखिए आप, this negative cycle is reachable from source, then the vertices in the cycle, जो vertices cycle में हो, जैसे कि C and F, and those vertices, ये भी बहुत important point है, those vertices that are reachable through the cycle, जो भी vertices cycle के through आप reach कर सकते हो, कौन सी vertex? G. G is reachable via this cycle. Via this cycle, G is reachable. So such vertices, right? Those vertices that are in the cycle and those which are reachable via the cycle, shortest paths are not possible. Shortest paths are not possible to such vertices. You cannot have shortest path to the vertices that are in the cycle, negative weight cycle, and those which are reachable via the cycle. Shortest path are not determinable. I am sure you might have got an idea कि why it is not possible. ये भी आप समझ गए होंगे कि आप कोई भी algorithm होने दीजिए, चाहे वो कोई भी strategy का हो, greedy का हो, या dynamic programming का हो, या backtracking का हो, या branch and bound, या heuristic, or any type of approach you follow, you cannot have shortest path. ये हो ही नहीं सकता क्योंकि minus infinity हो जाएगी. You can never find a better value. It is minus infinity. So therefore that's why no algorithm can work in case if the graph has negative weight cycle reachable from source. Right? Now positive weight cycle रहे with negative weightage, shortest path is determinable, shortest path is possible. ये बहुत इंपॉर्टेंट का कंक्लूजन है. ये जो मैंने आपको अभी बताया, बेस्ड ऑन दिस देयर वर थियोरेटिकल रीजनिंग क्वेश्चंस इन अर्लियर पेपर्स. जितना भी मैंने अब तक डिस्कशन किया ऑन शॉर्टेस्ट पाथ, देयर वर रीजनिंग क्वेश्चंस, डायरेक्ट क्वेश्चंस आस्क्ड ऑन दिस. सो अगर आप ये थ्योरी जो मैंने पढ़ाई अभी अंडरस्टैंड कर लिए, तो यू कैन डायरेक्टली आंसर सच क्वेश्चंस. यू कैन डायरेक्टली आंसर सच क्वेश्चंस. तो चलिए, बेस्ड ऑन दैट, विदाउट एनी डिले, we'll start our discussion with single source shortest path Dijkstra's algorithm. Single source shortest paths Dijkstra's algorithm. ठीक है, I'll take a sample graph for this. एक ग्राफ ले लूंगा मैं, so that we can apply the greedy strategy onto it. I'll take the following graph. Let's say vertex 1, vertex 2, 5, 4, and this is 3. It's a directed graph. The graph may be directed or may be undirected. Both can work. So I'll work for both. I will first work out for directed graph, then I will work out for undirected graph. Both will work out. और दो slightly different procedures है, हम वो भी देखेंगे. Same algorithm is same Dijkstras algorithm, लेकिन approaches are slightly different. जो मेरी terminology में मैं बोलता हूँ matrix method and spanning tree method, मैं आपको दो भी approaches बताऊंगा. There is one more vertex 6. And I have connectivity like this. $35. This is 10. This is 45. This is 50. 15. This is 20. 15. And this is 20. This is 10. I hope all the edges are marked. You can see this is a simple directed graph I have taken for making a trace of Dijkstras algorithm. Kindly see on board. हम यहाँ पर मान के चलेंगे कि the graph is represented in the form of cost adjacency matrix. और मैं यहाँ पर मान के चल रहा हूँ कि आपको पता है what is cost adjacency matrix. Cost adjacency matrix is a sequential representation of the graph. It is represented in the form of a two-dimensional matrix of order n cross n, where n is the number of vertices. And 1 to 1 there is no edge, 1 to 2 there is an edge, so cost of it is 50, 1 to 3 there is an edge, cost is 45, and so on. 1 to 4 cost is 10, 1 to 5 there is no edge, so हम mark करेंगे infinity. 1 to 6 there is no edge, mark करेंगे infinity. So in general I would write like here, Cij is edge cost between the vertices I and j. This is edge cost. और हमें चाहिए path cost. हमें चाहिए path cost. I want to find the shortest path from vertex source, whatever may be the source, to all the vertices. Source 1 भी हो सकती है, source 2 भी हो सकता है, source can be any vertex. So generally we will indicate the source vertex. Source vertex, let us indicate in terms of our notation as V0. V0 can be anything. Like I will work out the problem for V0 being 1. Later आप V0 for 2, 3 कोई भी vertex से आप कर सकते हैं. The first method of Dijkstra algorithm तो Dijkstra का है. First जो interpretation है मेरा, I will call it from my side. It is not in any textbook or literature. I will call it as matrix approach. I will explain you through matrix approach. फिर वही algorithm I will show you in the form of a tree structure. Generally हम बोलेंगे spanning tree. Both I will show. So in matrix form I will have a simple matrix with two columns. Two columns. In the first column I will call it as vertex selected. Vertex selected. कौन सी vertex आप select कर रहे हो at every step. And here in the second column I will mark it like destination d value. अभी मैं बताऊंगा आपको what is d value. ये बहुत understand करना बहुत important है. What is d value? I will tell you. So first I will mark all the destinations. हमारे पास 6 vertices है, so I will put all the vertices initially. All the vertices 1 to 6. As I said, any vertex can be selected as source. Any vertex can be selected as source. So in the first step, we will select the source as 1, let us say 1. So that means I want to find the shortest path from 1 to all the other vertices. So there is no meaning in finding shortest path from 1 to 1, I will put a dash. अब हमें यह समझना है कि what is this d value. यहाँ पर मैं लिख दूंगा, please understand. D of any vertex x, please follow me, this point is very important. D of any vertex, d value of any vertex x is nothing but cost of the path from source V0 to destination vertex x. X is the destination vertex. Cost of the path बता रहा हूं मैं आपको, not edge. Cost of the path from vertex V0 source to x. Cost of reaching the vertex x from V0 is given by d of x. maybe till that time you can say, or so far. Finally जब हमारा algorithm हो जाएगा तो final d values in the last row, will represent the cost of the minimum cost paths. ठीक है, चलिए स्टार्ट करते हैं. कैसे करेंगे? ये है greedy approach, और greedy method आपको मालूम है works in a stepwise manner. At every step out of available option, greedily select that option which satisfies your objectivity. अब हम स्टार्ट कर रहे हैं vertex 1 पर. If you look at this graph carefully, I see that I cannot basically find, I don't have an edge from 1 to 5, so I don't know what is the cost of that, right? So in the first step, initialization of greedy method, what we do is, because the cost adjacency matrix is given, so we try to put all those vertices which are directly adjacent from the source with their cost value, with their edge cost value. So if you see the graph from 1, I have an edge to vertex 2. So I say that so far I know the best possible path to vertex 2 is 50. Maybe I can have better, but so far right now, without visiting other vertices, direct edge cost can be the best possible to start with. So direct edge cost 1 to 50. Okay? I will slightly reduce. Okay. Chaliye, 1 to 50. 1 to 1 there is no meaning. Then 1 to 3, do I have an edge from 1 to 3? Yes, I have an edge from 1 to 3. What is the cost? The cost I will put 45. So this initialization will be done based on cost adjacency matrix to all those vertices which are reachable from the source with direct edge. 1 to 4 there is an edge, yes, with a cost value of 10. 1 to 5 there is no edge, so therefore cost value infinity. 1 to 6 infinity. Infinity means so far I don't know the shortest path. I don't know the shortest path to that vertex so far. Okay. So far best possible path has cost value 50, 45, 10. So from now the vertex selected is 1. What are the other vertices which are not selected? The not selected vertices are 2, 3, 4, 5 and 6. 2, 3, 4, 5 and 6. So among the vertices not selected so far, please follow bacho. Among the vertices not selected so far, select that vertex which is having the least d value. That is greedy approach. Greedy ये बताएगा कि from the options, greedily select that option which satisfies your objectivity, right? So among all the options, the one having the least d value is going to get selected. So that means this is having the least d value. Which one? Vertex 4. So that means in the next step I am going to add vertex 4 in my selection. Vertex 4 is going to get added. अब यहाँ पर हमें एक important step carry out करना है. Can anybody tell me what operation do I need to do now? What operation हमें क्या करना चाहिए अब after the addition of vertex 4 in my partially constructed vertices so far or included vertices so far? What operation should I carry out? Come on, before making a next selection, what operation should I carry out? That is the major important part of Dijkstras algorithm. What is the name given to that step in the literature? Okay, 142 there is a path. So what do you call that process as? I want to know from you what is that process known as. Come on. After the selection of vertex, after the selection of vertex 4, what is it that we have to carry out? Satyam Binayak, you are exactly right. I will write it in the next step. I will have to carry out a process called relaxation. Here terminology is also very important, please. आपको interviews में काम आएंगे. Relaxation process has to be carried out. What is relaxation process? Please understand. My source is 1, I have selected vertex 4 with a direct edge. It is quite possible that earlier there was some vertex x to which the cost of the path, like for example, was C1. This cost of the path was having value C1. Maybe through some other path, C1. Now it is possible that I can reach x via 4. Earlier I was reaching x not via 4, via some other path, maybe some other value, some other means. I was reaching with a cost value of C1. Now I can reach x via 4, right? With a cost value, this total cost value of C2, right? With the cost value of C2. So here I say if C2 is less than C1, new cost path is less than the earlier cost, new cost C2 via 4 is less than C1, then don't you agree that I have discovered a better path to vertex x from 1? Again I am repeating. There is a vertex. There is a vertex x. Let us say there is a vertex x, right? And I have found that from vertex 1 to x to reach vertex x, to reach vertex X, I was having a cost value C1. I was saying that X was reachable from 1 with a cost value C1 somehow using some path. That's what I said, using some path. I don't know what is that path. Now after selecting 4, it is possible that X may become reachable from 1 via 4. ये बता रहा हूं मैं. It may be possible that X may become reachable from 1 via 4, and let's say that this total cost is C2. So if C2 is less than C1, then I say I got a better path to vertex X from 1 via 4. So in that case, I should update this D value from C1 to C2. So this process is called relaxing the D value of vertex X. So what should I do? After selection of any vertex, I should see to carry out the relaxation process of all those vertices which are not selected. So this is another important point. Relaxation process should be carried out only for those vertices. Only for those vertices. Relaxation should be carried out only for those vertices which are not selected so far. Which are not selected so far. ये भी बहुत important point है. Naturally, you cannot relax the values or D values of those vertices which are already selected. Already selected का मतलब है कि you have already found the shortest path. फिर से कोई shortest path find out करने की जरूरत नहीं है. So relaxation has to be carried out only for those vertices which are not selected so far. चलिए अब देखेंगे ये rule यहाँ पर apply करेंगे हमारे previous example में. देखिए आप, मतलब 4 का value तो final decide हो गया 10. I can't have a better path to vertex 4 with a cost value less than 10. That's for sure. तो अब हम 4 की रिलैक्सेशन कभी भी नहीं करेंगे. 4 डेस्टिनेशन 4 की डी वैल्यू कभी भी रिलैक्स नहीं करेंगे. चलिए अब देखेंगे 1 to 1 there is no meaning. 1 to 1 there is no meaning. 1 to 2. Earlier if you look at the graph earlier, यहाँ पे generally I have seen people going into confusion. 1 to 2 cost value 50. Now with the inclusion of 4, can I reach, look at that, 1 to 4 with the cost value 10. Can I reach 2 via 4 from 1? Some people say yes. No, you cannot, because I don't have an edge from 4 to 2. लेकिन बच्चे क्या गलती करते हैं यहाँ पर? No sir, I can go to 5 and then to 2. मैं वो पूछ रहा हूँ, are we going to talk about 5 now? No, because 5 is not selected so far. हमारे पास जो vertex selected है only 1, 4. So using these vertices in the set S, in the vertex selected set, अगर हम इसे बोलेंगे set S, using the vertices in the set S, is it possible to reach 2 with a better cost? ये मतलब है नहीं, because there is no edge from 1 to 2. So 4 to 2. 4 to 2 की edge cost value infinity रहेगी, and this is already 50, so no change in 50. So this will remain 50. समझ गए होंगे आप? Now come to vertex 3. Can I reach 3 from 1 to 4? 1 to 4 there is an edge, but 4 to 3 there is no edge, so I can't reach, so this will remain 45. 10 is finalized already. Now 5. Earlier 5 was not reachable. Now can I reach 5 via 4? Yes, I can reach. How? 1, 4, 5. With a cost of 10 plus 15, 25. 25 is less than infinity, so I change 25. 6 is not reachable at all, so I'll mark it infinity. So which D value got relaxed? D value of vertex 5 got relaxed from infinity to 25 with the selection of vertex 4. This is the meaning. अब इसके बाद हम repeat करेंगे next. What repeat? Among the vertices not selected so far, select the vertex having the least D value. Among the vertices not selected, 2, 3, 5, 6, select the one having the least D value who had 25. That is vertex 5. So I should add vertex 5, right? I should add vertex 5 in my set here, in my selection 1, 4, 5. And I carry out, repeat the same process recursively. That is, among those vertices which are not selected, try to relax their value. So therefore we will see, can I relax, because 2 is not selected, can I relax the D value of vertex 2? Can I relax the D value of vertex 2? Check करेंगे. Is it possible to explore a path to vertex 2 from this set of vertices in the set S? 1, 4, 5, 2. Yes, there is a path. 1, 4, 5, 2. Cost कितना है? 10 plus 15, 25 plus 20, 45. 45 is better than 50, so therefore change. The value D value got relaxed from 50 to 45 for vertex 2. Look at that beauty of the relaxation process. 1453 या 153 तो पाथ ही नहीं है. 1453, yes, path is there, 1453, but that cost is, look at this, 25 plus 35, it is greater than 45, so no relaxation. Even though path is there, but no relaxation. This is not going to be relaxed, this is finalized. So among the next step, among the vertices not included so far, कौन से? 2, 3, 6. Select the one having the least d value. कौन आएगा? 2 या 3? Let us say 2. We add 2. तो हम डालेंगे 1, 4, 5, 2. This is already done 45. Can we relax the value of vertex 3 from the set of vertices 1, 4, 5, 2? देखिए आप 1, 4, 5, 2. It's not, sorry, 1, 4, 5, 3. 1, 4, 5, 3 already हमने देखा कि जो so cost is more than 45, so no possibility of any change. 1, 2, 5 वो भी 60 हो जाएगा cost, that is 45, that is better, right? Earlier cost itself is better, no change. So this remain 45. These are finalized 10, 25, infinity. So final step में आप vertex 3 भी add कर लेंगे, right? In the final step, so 1, 4, 5, 2, 3. So 45, 45. This is 10, this is 25. These remain infinity. क्यों? 6 is not reachable at all. Look at this. 6 is not reachable from 1, तो उसकी cost value infinity रहेगी. So therefore, the last row will indicate to me the cost of the shortest path from vertex 1 to all. Shortest path from 1 to 2 is 45. Shortest path from 1 to 3 is 45. Shortest path from 1 to 4 is 10. Shortest path from 1 to 5 is 25. And 6 is not reachable. This is called matrix method. अब मुझे आप यहां पर कोई बताएगा कि what is the drawback of this matrix method? Drawback पूछ रहा हूं मैं, कोई problem या limitation या failure की बात नहीं कर रहा हूं. एक simple drawback of this approach, if you solve the problem this way, there is one simple problem. देखेंगे कौन बताएगा what is the simple problem with this approach? ये approach which I call matrix approach of Dijkstras algorithm. What is the simple problem with this? Simple drawback of this? Simple limitation of this? Can anybody tell me? Can anybody tell me what is the simple drawback of this approach? Nobody? Not space more. No? Yes, Satyam Binayak is correct. This will give you the shortest path values, cost values. But path is not shown. Path is not shown. आपको ये बता रहा है कि 45 है, लेकिन कौन से पाथ से आप 45 रीच कर रहे हो, we don't know. What is the shortest path from 1 to 2? We don't know. What is the shortest path? Path, we don't know. Path is not known. तो अगर आप path मालूम करना चाह रहे हो, then we have to go for the same Dijkstras algorithm. Algorithm is same, लेकिन उसका interpretation is different. That is through spanning tree approach. So that I will go with another example, right? Another example. So that I will show you here. ठीक है, हम यहीं पे कर लेंगे. I'll take another example of a graph. I'll take another example of a graph. Another graph I will take, and this case I will take a undirected graph. Look at this graph. Take V0 is equal to 1. And let us apply the shortest path, Dijkstras single source shortest path algorithm, right? Same algorithm in a panning tree approach. So how? So I will take first the skeletal structure of the graph. पूरे हम vertices ले लेंगे. चलिए स्टार्ट करेंगे. Source is V0, right? Source is V0. This is V0. So what is the first step? What is the first step? All those vertices which are directly adjacent from one should be, we should mark their d values. हम यहाँ पे क्या करेंगे? Convention follow करेंगे. जो d values है ना, d values जो मैंने पहले आपसे कहा था, we will mark the d values outside the node. So for example, if this is node x, whatever value I mark it here, this is the d value outside the node. 2 is adjacent from 1, so therefore the d value is 55. This is via direct link to 1 to 2. And this is 25. This is direct link to 3. This is 45. This is direct link 4. This is like my first row. This is like my first row. 5, 7, 6 and 8 are not reachable from 1 directly by means of an edge. तो इसका मतलब यह है कि their d values will be infinity, 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 infinity. ठीक है? Please follow this approach because there was a gate question asked. और अगर उसके लिए आप ये approach follow करेंगे तो you get the answer faster than matrix approach. ठीक है? Matrix approach is the traditional thing that you find in the textbook. लेकिन टेक्स्टबुक में ये मेथड ऐसे इस तरीके से डिस्क्राइब नहीं है, तो आप यहाँ फॉलो कर लीजिए. तो प्लीज सी. तो व्हाट डिड वी सेड फ्रॉम द अनसेलेक्टेड? ये देखिए पूरे अनसेलेक्टेड वर्टिसेस है. सेलेक्ट द वर्टेक्स हैविंग द लीस्ट डी वैल्यू. कौन सी वर्टेक्स होगी? देखिए आप, दिस इज 55, दिस इज 25, दिस इज 45, दिस इज इंफिनिटी, 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 इंफिनिटी. मतलब वर्टेक्स 3 इज हैविंग लीस्ट डी वैल्यू. तो आई मेक ए सिलेक्शन दैट इज वाया डायरेक्ट लिंक 1 to 3. उसके बाद 3 सेलेक्ट हो गया. 3 सेलेक्ट होने से हम रिलैक्सेशन के लिए देखेंगे. उसके लिए ग्राफ में देखिए व्हाट वर्टिसेस आर रीचेबल फ्रॉम 3. फ्रॉम 3 इन द ग्राफ 5 इज रीचेबल. तो 5 इज रीचेबल एट ए कॉस्ट ऑफ हाउ मच? एट ए कॉस्ट ऑफ हाउ मच? मतलब ये इंफिनिटी से चेंज हो जाएगा. इंफिनिटी से चेंज हो जाएगा. आई कैन रीच 5 एट ए कॉस्ट ऑफ 40. मतलब 40 + 25, तो इसकी वैल्यू हो जाएगी 65. दिस इज वाया वर्टेक्स 3. इज वाया वर्टेक्स 3. राइट? 5 इज updated. So we have changed the d value of 5. It means that 5 is reachable from 1 at a cost of 65 via 3. ये मतलब है इसका. समझ गए? And there are no other vertices reachable from 3, so no relaxation. चलिए कंटिन्यू करिए. From the unselected vertices, select that vertex having the least d value. देखिए 255 है, ये 45 है, ये infinity, 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 65. 45 is least via 4, direct link 1 to 4. ये select हो गया. After selection of 4, which vertex d value may change? Which vertex d value may change after selection of 4? तो 4 से adjacency किस पे है? I have adjacency to vertex 8 and to vertex 5. ये देखिए आप, यहाँ पे एक important point है. I can reach 5 via 4 also. Earlier it was reachable via 3 at a cost of 65. Via 4 also it will be 65. अगर same cost हो तो हम relax नहीं करेंगे. Relaxation will be done only if I have a better path, lesser path cost. Relaxation नहीं होगा 5 का, लेकिन 8 का होगा. 8 का रिलैक्सेशन होगा. राइट? इट गेट रिलैक्स्ड एज व्हाट? कम ऑन, फ्रॉम इंफिनिटी इट गेट रिलैक्स्ड एज 75 वाया 4. चलिए आगे बढ़ेंगे. अमंग द अनसेलेक्टेड वर्टिसेस 55, 75, 65, इंफिनिटी, इंफिनिटी, नेचुरली 2 सेलेक्ट होगा. Selection of 2, I can reach 5. Can I have a better cost? Yes. 55 + 5, 60. 60 is better than 65. मतलब ये चेंज हो जाएगा. 65 से भी चेंज हो जाएगा ये. 260 via vertex 2. That's all. There's a concept. अब इसके बाद among unselected vertices, these 60, infinity, infinity, 75, select the one having the least d value. कौन सी vertex है? 5. With a cost value 60. 5 is reachable via 2. So link डाल लीजिए यहाँ पर 2. Now after selecting 5, which vertex d values will change? Certainly 6 will change. 6 will change. 7 will also get changed. So a 60 plus 35, this become 95 via 5. And this will become 60 plus 15, 75 via 5. Repeat. Among the unselected vertices, 8, 7 and 6. Select the one having the least d value. ये भी select कर सकते हो या ये भी select कर सकते हो. Let us select 8 via 4. Having selected 8, can there be a possibility? देखिए आप 75 plus 50, 125 होगा. 125 is not better than 75. No change. चलिए next step. Among the unselected vertices 7 and 6, select the one having the least d value. 75 is least via 5. So make a selection. अब 75 सेलेक्ट होने के बाद वर्टेक्स 5 सेलेक्ट होने वर्टेक्स 7 सेलेक्ट होने के बाद आई कैन रीच 6 वाया दिस पाथ एट अ कॉस्ट ऑफ हाउ मच 75 plus 10 85. 85 is better than 95, so I should relax this value. So this will become 85 via 7, and that is the only vertex remaining to get selected, and that we are selecting via 7. This is my the final values which I am putting here. Please observe the final values which I am putting here: 60, 55, and this is 25, this 45, this 75, 75, 85. These are the shortest path values from vertex 1, and the paths are also shown. That is the advantage of this approach. The paths are also shown. If you observe, this is also a spanning tree of the graph. Is it not a spanning tree? Right? 4 to 5. 4 to 5 इसलिए select नहीं हुआ. I have already told you this is an important concept. Relaxation should be done here. If you want, I will write a point. Shifu Khadir, you are saying, I told you that point. Relaxation should be carried out. Relaxation should be carried out. Relaxation should be carried out only if a strictly shorter path is seen. This is an important step. So 4 to 5, the cost would have been 45 plus 20, 65. Earlier already 65 was there. So if I am having the same cost path, why should I relax? I should relax. Remember the rule. I should relax the d value only if I have a strictly shorter path. Strictly matlab less than, not equal to. ठीक है? That is the point. I have marked that as a comment. ठीक है, चलिए. So, do you agree this is a spanning tree of the graph? Come on, say yes or no. Do you agree with me that this is a spanning tree of the graph? Yes. Is it a spanning tree of the graph? Is it a spanning tree of the given graph or not? Yes, it is a spanning tree. तो हम इसे बोलेंगे single source shortest path spanning tree. Shortest paths spanning tree. Spanning tree कई किस्म के होते हैं, please. Many types. This single source shortest path spanning tree. लेकिन मेरा आपसे क्वेश्चन ये है, this could be a 1 mark gate question. Answer me orally, not thinking much. Is single source shortest path spanning tree same as minimum cost spanning tree? Come on. Most of the time I see people going into confusion with this statement. मैं पूछ रहा हूं, is single source shortest path spanning tree क्या वो minimum cost spanning tree है? Same है दोनों? Are they same? Minimum cost spanning tree and single source shortest path spanning tree, are they same? Yes or no? Come on. Are they same or different? Single source shortest path spanning tree and minimum cost spanning tree, are they same or different? They are same or different. वहां पे लिखिए आप same or different, ये लिखिए. Because when you are saying yes or no, I cannot understand what are you trying to say. They are different. They are different. So मैं ये चाह रहा हूं आप proof कीजिए for this graph, please. For this given graph, हमने single source shortest path spanning tree यहां पर उतारा. अब आप बताइए what will be the minimum cost spanning tree for this graph, assuming that you know the concept. Can you show what will be the minimum cost spanning tree of this graph and prove that they are different, they are not same? Minimum cost spanning tree of this graph. So if you take the skeletal structure, 1, 2, 3, 4, and here I have 5, here I have 6, here I have 7, and here I have 8. Like this. So if you follow Kruskal's algorithm, which is supposed to be the faster approach, so I will start with that edge which is having the least cost. So this is 5. Next least cost 10, between 7 and 6 we add. Next least cost value 15 present between 5 and 7 we add. Then we have 20 between 4 and 5 we add. Then 25 is present between 1 and 3 we can add. And then we have 30 present between 4 and 8 we can add. Then we have 35 discarded. 40 present between 3 and 5 we can add. So therefore this completes the spanning tree. Because the graph has got 8 vertices, we need 7 edges. So therefore I have added 7 edges. 1, 2, 3, 4, 5, 6, 7. This is minimum cost spanning tree. You can check. This is different from single source shortest path spanning tree. This is different from single source shortest path spanning tree. Both are different. अगर आप टाइम कॉम्प्लेक्सिटी की बात करेंगे ऑफ मिनिमम ऑफ सिंगल सोर्स शॉर्टेस्ट पाथ एल्गोरिथम डाइकेस्ट्रास एल्गोरिथम विद कॉस्ट एडजेसेंसी मैट्रिक्स एंड नॉर्मल अप्रोच ऑर्डर ऑफ n स्क्वायर, अगर आप उसमें क्यू डेटा आई मीन हीप अगर यूज करोगे, हीप if you use heap data structure to store unselected vertices, then the complexity will get reduced to as n plus e log n. So that I'm leaving it for you. You can see the algorithm from Corman textbook or any other textbook, and then you can see e log e or n plus e log n can get reduced to e log e like that. So that is the time complexity of Dijkstra's algorithm for single source shortest path. एक previous gate question लूंगा मैं यहाँ पर, previous gate question लूंगा. Please you try to answer that problem. Come on, this is my question. I will describe to you and then you can give me the answer for this. Give me the answer for this. I'm going to describe the algorithm problem here. Applying, look at this. I will make a slight change here. I'll make a slight change here. Okay. This is also true. Chaliye. Look at the question. Applying Dijkstra's algorithm over the given graph, which path, this is important, which path is reported from S to T? This is S, this is S, this is T. Come on, I'll give you 2-3 minutes of time, 2-3 minutes of time. Please apply Dijkstra's algorithm and tell me which path is reported because, क्यों ऐसे पूछ रहे हैं, we will see, because if you see, there are multiple paths available between S and T having the least cost value. देखिए आप first path is SACET, SACET, the cost is how much? 4, 5, 6, 6 plus 4, 10. So first option is SACET, first option. Option B, और एक भी path है SDT, actually यहाँ पे miss हो गया है, I'm drawing it. SDT, 7 plus 3, 10. C, SBDT, look at this, SBDT, 3 plus 4, 3 plus 4, 7, 7 plus 3, 10, SBDT. D. If you look at another one, SACEGT, 4, 5, 6, 7, 8, 9, 10. SACEGT. 4 options I have given, multiple options A, B, C, D. So my question is, among these 4, which path will be reported? See, all these options have same cost value 10 please. ये सभी के option के cost value है 10. तो मतलब shortest path का जो cost है ना from S to T it is 10. That is for sure. लेकिन question is which path will be reported by Dijkstra's algorithm? That is what is important. This is a gate question for 2 marks. Gate question for 2 marks. So if you have not solved this question earlier, can you please work out now sincerely and seriously and tell me what will be the answer for this question? Come on, I'll give you some time, 3-4 minutes of time. Think well, work out as a matter of practice and tell me what is the answer for this question. Come on, boys and girls, please work out. What will be the answer? Well, I hope you are working, please. Satyam B. Naik is saying SACET, okay. What about other people? Muhammad Asif is also saying A. Many people are saying A. And others also, I hope you are doing. So which approach is better for solving this problem? Are you going to work out using matrix method or are you going to work out using spanning tree method? Spanning tree, क्योंकि हमें path चाहिए, cost नहीं चाहिए. Path के लिए आपको spanning tree approach जो अभी हमने देखा, that was more suitable. Earlier हमने undirected graph के लिए apply किया था, अब directed graph, ये directed graph है, spanning tree approach. So I'm starting to work, please observe here. S is my source here, S. So initially I will mark the cost values to D value to vertex A as 4 and to B as 3. These are the, and D as 7. This is the first part. 4 because A is reachable, D is reachable, B is reachable. The minimum cost value of B, we are going to make a selection of B. After selecting B, देखिए आप, we are not going to relax this value. Why? Because 3 plus 4 it becomes 7, already 7 है, हम change नहीं करेंगे. हमने कहा, if you have a better path cost, better cost, we will change it. Otherwise, we won't change. फिर उसके बाद कौन सा vertex select होगा? Vertex 4, vertex A with cost value 4 will get selected. Right? After selecting 4, the D value of vertex C will get changed to 5 via A. This is via A, 5. And there is no other vertex, so therefore that we are not going to do. Now the unselected vertex, the remaining all infinity, I have not marked earlier, now I am marking infinity. Now with the selection of vertex 5 via 4, via A, the D value of which vertices will get selected. So first E become reachable, right? E will become reachable at a cost of how much? 5 plus 1, 6. This is via C. And from C, the D value, देखिए आप, this is 5 plus 3, 8. 8 is not better than 7, so we don't change. That's all. That is the only change that has happened. That is the only change that has happened. फिर उसके बाद क्या होगा? कौन select होगा? या 6 है, infinity, 7, infinity. So 6 select होगा. That is vertex E. Right? After selecting E, the D value of vertex G and T will change. G and T will change. G will change to 8 and T will change to 6 plus 4, 10 via E. Right? Via E. The moment I reach T via E, that's it, I can stop my problem, I can stop my algorithm. If I'm solving the exam, I should stop here now. Why? Because I have reached T. हमने कहा the shortest path की जो value है इस ग्राफ में वो है 10 and the moment I reach the first time T, that is my first path discover. उसके बाद दूसरे जो पाथ्स होंगे वो अपडेट नहीं करेंगे टी को. हमने कहा स्ट्रिक्टली शॉर्टर होंगे तो अपडेट करेंगे स्ट्रिक्टली शॉर्टर. अब यहां पर स्ट्रिक्टली शॉर्टर नहीं हो सकते, तो व्हाट इज दैट सिलेक्शन? दीज अ सिलेक्शन. सो फार दीज अ सिलेक्शन. तो आप अगर रिवर्स जाके पाथ देखेंगे तो इट इज टी फ्रॉम ई, ई फ्रॉम सी, टी फ्रॉम ए फ्रॉम एस. So this is my path, SACET. So therefore the correct answer is A. इस तरीके से. If you want, you can complete the problem, that is no issue. But in the exam, if you are working, you should stop here. You should not say that, no, I know how to solve the problem, I will continue to solve. It will be waste of your time. Correct? So that's the policy of this problem. This is the question. इसी तरीके का एक और एक क्वेश्चन था गेट पे, I mean in one of the exam. I will tell you what is that question. So please see here. I'll write down the question for you and you try to answer it. Consider, it's a simple one mark question, a weighted undirected graph. Let UV be an edge in the graph. It is reported that the shortest path from source S to U is 53 and the shortest path from source S to V is 65. Cost value is given to us. Follow, this is an interesting question. Then, what is true with respect to the edge cost or weight of the edge cost UV? What is true with respect to the edge cost UV or weight of the edge UV? Options can be given like this. The weight of the edge UV, W of UV, हम weight बता रहे हैं या weight of the edge cost हम बता रहे हैं, or if you want, because cost of the edge हम पूछ रहे हैं, तो we will write like cost of the edge C of UV is less than or equal to 12. B, cost of the edge UV is less than 12. C, cost of the edge UV can be greater than or equal to 12. Cost of the edge UV is greater than 12. Come on, answer this question. What is true? Some simple reasoning questions like this are also important this way. So if you have the basic concept, then you can tell me the answer. If Qadir is saying D. If you are changing your answer from D to C. Ishan Dalane is saying A. Is it K? Muhammad Asif, you are telling A. Come on, be careful, boys and girls. Be careful. Apply the concept. What is true with regard to the edge cost between U and V? The concept of relaxation process has to be applied here. Okay. Let's try to understand it. I'll slightly squeeze it. Let's apply. Source vertex S. There are two vertices U and V. It's a undirected graph. There is an edge between U and V. There is an edge between U and V. It is reported that the cost of the path, shortest path between S to U, is having value 53. And the cost of the path from S to V, path hai ye, this is 65. Using some intermediate vertices, we don't know. Some intermediate vertices. Suppose if I say this cost value is X, this edge cost is X, edge cost. This is path. This is also path. This is edge. And edge weight is X. 53 to 65, right? So what is the difference? 65 minus 53. What is the difference? 12. The question is, listen, question is, can this value X, first question, can this value X, can this be less than 12? First point. First point, can this be less than 12? Say yes or no. अब बताइए मुझे before options. Can X be less than 12? क्या ऐसा हो सकता है? Come on. It is impossible. ऐसा हो ही नहीं सकता. X can never be less than 12. पहला कंक्लूजन यह है कि X can never be less than 12. क्यों? अगर ये लेस देन 12 होता तो हमारा शॉर्टेस्ट पाथ टू वर्टेक्स V वुड हैव बीन 53 प्लस वैल्यू लेस देन 12, 53 प्लस 11, 53 प्लस 10 फॉर एग्जांपल, लेस देन 12. अगर 10 ले आप 63. लेकिन ये बता रहा है एल्गोरिथम में, प्रॉब्लम में, कि शॉर्टेस्ट पाथ टू वर्टेक्स V इज डेफिनेटली 65. इट इज नॉट लेस देन 65. X की वैल्यू लेस देन 12 हो ही नहीं सकती. तो मतलब रूल ऑफ एलिमिनेशन से ये ऑप्शन भी गया, ये ऑप्शन भी गया. राइट? रूल ऑफ एलिमिनेशन से ऑप्शन ए एंड बी आर गॉन. अब रही बात ग्रेटर देन और इक्वल टू 12 और ग्रेटर देन 12. अब यहां पर आपको स्लाइटली सिंपल वे में अप्लाई करना है कॉन्सेप्ट. सिंपल वे में अप्लाई करना है कॉन्सेप्ट. राइट? तो प्लीज ऑब्जर्व. सेकेंड पॉइंट मैं पूछूंगा, कैन एक्स, बी केयरफुल बॉयज एंड गर्ल्स, कैन एक्स बी इक्वल टू 12? क्या 12 हो सकती है? कमान कमान. यहां पर जनरली स्टूडेंट कंफ्यूज हो जाते हैं. कैन एक्स बी इक्वल टू 12? Say yes or no. Say yes or no. Can X be equal to 12? 12 हो सकती है ना? Yes. 12 हो सकती है. हो सकती है. सेम कॉस्ट. पिछला एग्जाम्पल, पिछला प्रॉब्लम जो हमने सॉल्व किया, इक्वल कॉस्ट हो सकते हैं. मल्टीपल एडजस्ट से, मल्टीपल पाथ से इक्वल हो सकते हैं कॉस्ट. इक्वल टू 12. इक्वल टू 12 इज पॉसिबल. ठीक है. अब इक्वल टू 12 का तो ऑप्शन नहीं है वहां पे. कैन इट बी ग्रेटर देन 12? ये भी हो सकता है. Can it be greater than 12? Is that also possible? Come on. Can it be greater than 12? Definitely it can be greater than. Why not? It can be greater than 12. It can be definitely greater than 12. So therefore the answer is greater than or equal to 12. So you have to work out like this. It can never be less. Less हो ही नहीं सकता. It can be either equal or greater than 12. So therefore the correct answer is C. Is C. So those of you say C, excellent, good. So be ready to work out such simple problems. These are 1 mark questions, reasoning questions. So my dear students, मैं ये बताना चाह रहा हूँ, point number 1, taxonomy of shortest path की clarity रखिए. Which problem is solvable by which algorithm, clarity रखिए. Under which circumstances negativity अगर हो तो कब आप solve कर सकते हो problem, कौन सा algorithm apply कर सकते हो, ये भी clear रखिए. Working of single source Dijkstras algorithm, both matrix approach and spanning tree approach, both of them you remember very carefully. What data structures are used in the implementations of Dijkstras algorithm, be clear. अगर इस कॉन्सेप्ट के अराउंड आप प्रिपेयर कर लोगे, राइट? व्हाट इज रिलैक्सेशन प्रोसेस इफ यू नाउ गेट इट, राइट? तो यू कैन क्लैरिफाई इट, यू कैन क्लैरिफाई इट. अगर आप इतना कर लेंगे तो आई एम वेरी श्योर यू कैन सॉल्व एनी क्वेश्चन बेस्ड ऑन दिस टाइप ऑफ प्रॉब्लम्स इन द एग्जाम. ठीक है, अब हम क्या करेंगे, रिमेनिंग आई हैव अनदर 10 मिनट्स, सो आई विल टेक अप सम क्वेश्चंस फ्रॉम द टॉपिक्स व्हिच आई हैव नॉट डिस्कस्ड हियर, लेकिन आप सॉल्व कर सकते हो. जैसा कि somebody asked me earlier, जॉब सीक्वेंसिंग विद डेडलाइंस, एक गेट क्वेश्चन हम सॉल्व करेंगे, राइट? सम क्वेश्चंस लाइक another greedy problem we generally write in short called JSD, job sequencing with deadlines. Those of you who do not know, मैं एक सिंपल तरीके से डिफाइन कर दूंगा. This is a problem related to CPU scheduling. This is a problem related to CPU scheduling with deadlines. तो प्रॉब्लम डेफिनेशन क्या है यहां पर मैं लिख दूं आपके लिए, प्लीज ऑब्जर्व. JSD प्रॉब्लम. वी आर गिवन ए सिंगल CPU. एक CPU है. वी आर यूजिंग नॉन प्रीएम्प्टिव मल्टी प्रोग्राम्ड ऑपरेटिंग सिस्टम एनवायरनमेंट. ये हमने ऑलरेडी देखा, राइट? नॉन प्रीएम्प्टिव मल्टी प्रोग्राम्ड ऑपरेटिंग सिस्टम यूज कर रहे हैं. देयर आर n प्रोग्राम्स और प्रोसेसेस, जिसे हम बोलेंगे यहां पर जॉब्स. देखिए, जॉब, प्रोसेस, प्रोग्राम्स, टास्क, एप्लीकेशन, ये सब सेम है. तो n जॉब्स. ऑल जॉब अराइवल टाइम इज 0. ईच जॉब बर्स्ट टाइम इज 1. ईच जॉब इज एसोसिएटेड विथ अ डेडलाइन, जिसे हम बोलेंगे DI. और ईच जॉब इज एसोसिएटेड विथ प्रॉफिट, PI. Correlation between job deadline and profit is that if you complete a job within the deadline, then you get profit PI. अगर आप प्रोसेस को अपने डेडलाइन में अगर कंप्लीट कर रहे हो तभी आपको प्रॉफिट मिलेगा, वरना नहीं मिलेगा. एक्टिविटी सिलेक्शन प्रॉब्लम, देखिए अल्फा, what I'm trying to say is there are innumerable problems which can be solved based on greedy method, dynamic programming, backtracking, divide and conquer. तो सिलेबस में है या नहीं बोल सकते आप. एल्गोरिथम्स का कॉन्सेप्ट ये है कि आपको कोई भी एक नया प्रॉब्लम दिया जाएगा और आप उसका एक्सप्लेनेशन दिया जाएगा एक पेपर में और आपको वर्कआउट करना पड़ेगा. तो सिलेबस का कोई सवाल ही नहीं है, राइट? यू हैव टू प्रिपेयर फॉर द स्ट्रैटेजी के बेसिस पर आप कैसे सॉल्व करेंगे वो आपकी प्रैक्टिस के ऊपर डिपेंड करेगा, राइट? एक्टिविटी सिलेक्शन कैन बी आस्क्ड, व्हाई नॉट, इट कैन बी. So if a job is completed within the deadline, we get profit PI. If I don't complete the job within the deadline, then we don't get the profit. तो यहां पर हमें क्या करना है? We need to select a subset of given jobs. Given कितने हैं? N of given jobs, such that the jobs in the subset are completable within their deadlines. And maximize the profit. This is a problem. जैसे हमने कहा ग्रीडी के 2 पैराडाइम है, ऑर्डरिंग पैराडाइम है, सबसेट पैराडाइम है. ये सबसेट पैराडाइम है. क्लियरली आपको सबसेट सेलेक्ट करना है. Among the n given jobs, you need to select a subset of jobs. Right? Among the given n jobs, select that subset which is going to ensure that all the jobs in the subset are completable within the deadlines and give you maximum profit. ये हमें करना है. तो मुझे, before I proceed, let me ask one simple one mark question. The question is like this. The question is, let me see who will answer this. Question is, what is the size of solution space? Size of solution space of JSD problem. If you are having n jobs, what is the size of solution space? What is the size of solution space for n jobs? Come on. What is the size of solution space for n jobs? for JSD job sequencing with deadlines. Come on, one more question. Satyam Binayak, be careful, be careful, be careful. Come on, other people. Qadir is saying 2 power n. Come on, others. Logical learner 2 power n. Okay. Satyam Binayak, you are still saying n factorial. Can it be n factorial? Check. 2 power n. Why? बच्चों, अगर आप गौर से देखोगे तो आंसर यहां पर है. सेलेक्ट ए सबसेट ऑफ गिवन एन जॉब्स. ए सबसेट ऑफ एन जॉब मतलब एन अगर एलिमेंट्स हो तो नंबर ऑफ सबसेट्स कितने होंगे? नंबर ऑफ सबसेट्स बनेंगे 2 पावर एन. तो देयरफॉर 2 पावर एन. तो मैं आपको यह कहना चाह रहा हूं कि अगर आप ये प्रॉब्लम ब्रूट फोर्स अप्रोच से सॉल्व करोगे, ब्रूट फोर्स एन्यूमरेशन, तो आपकी टाइम कॉम्प्लेक्सिटी ऑफ द एल्गोरिथम वुड बिकम ऑर्डर ऑफ 2 पावर एन. लेकिन हम चाहेंगे टू वर्क आउट दिस क्वेश्चन यूजिंग ग्रीडी मेथड. ग्रीडी अप्रोच क्या है? राइट, अमंग द ऑल जॉब्स यू सेलेक्ट दैट विच इज हैविंग द maximum profit or minimum deadline, whatever, some approach. So now based on this understanding, you know by this time what is greedy method, what is greedy approach. अब वो basis पर आप मुझे ये जो question है, क्या ये workout करके आप मुझे बताएंगे these are the tasks T1, T2, T3, T4, T5, T6, 7, 8, 9. These are their profits, these are these deadlines, right? Each job हमने कहा arrival time of all jobs is 0. The burst time requirement of each job is 1. I'm having a single CPU, right? हर जॉब की अपनी डेडलाइन है, अपनी प्रॉफिट है. अब मुझे यहां पर वर्कआउट करके बताइए इसका आंसर क्या है. कम ऑन, इसका मैं क्वेश्चन यहां पर ये है, क्वेश्चन यहां पर लिख रहा हूं मैं आपके लिए. प्लीज ऑब्जर्व, आई एम राइटिंग डाउन द क्वेश्चन टू यू. क्वेश्चन इज नेक्स्ट पेज पे है, मैं यहां पे लिख रहा हूं. व्हाट जॉब्स आर excluded मतलब not considered in the schedule. Come on. What jobs are excluded in the schedule? Work out and tell me the answer, please. Let me see how many of you will tell me correctly. Come on, boys and girls, jaldi bataiye. What jobs among 9 jobs are excluded in solving the problem using greedy method? अगर आप जब greedy method से solve करोगे इसे, what jobs are excluded from the list? Excluded. Come on. I hope you are working. Some greedy strategy apply कीजिए. कौन सा जॉब हम पहले शुरू करेंगे, फिर कौन सा करेंगे, फिर कौन सा शेड्यूल करेंगे, like that, step by step, because greedy approach is stepwise manner. Apply local optimality at every step. That's the principle of greedy method. Profit is earned, profit is obtained if the job is completed on or before the deadline. On or before the deadline. आप तभी प्रॉफिट मिलेगा अगर आपका जॉब कंप्लीट होगा ऑन और बिफोर डेडलाइन. कम ऑन, आंसर अभी तक नहीं आया मुझे. T4 and T6 से सत्यम विनायक. ओके, कम ऑन बच्चों, जरा थोड़ा स्पीड भी जरूरी है आपके लिए. थोड़ा फास्ट वर्कआउट करने की प्रैक्टिस कीजिए, क्योंकि आपको क्या होगा, वरना एग्जाम में आपको टेंशन रहेगा. एक वो टेंशन से आप और स्लो हो जाओगे. राहुल कुमार T4 and T6. ओके, लॉजिकल लर्नर यू आर सेइंग T1. चेक इट प्लीज, चेक इट अगेन. यहां पर आपको गैंट चार्ट बनाना है. गैंट चार्ट बनाकर आप शेड्यूल करने हैं प्रोसेसेस को, कि कौन सा प्रोसेस पहले शेड्यूल करोगे, कौन सा सेकंड करोगे, कौन सा थर्ड करोगे. उस तरीके से वर्कआउट कीजिए. T4, T6, T8. ओके, शिफू खादिर, चेक इट अगेन. यू आर मेकिंग मिस्टेक आई सपोज. ये बहुत सिंपल प्रॉब्लम है. Alpha is saying T4 and T6. Okay. ठीक है, Get Easy is also saying T4 and T6. Good. प्रॉफिट कितना होगा ये भी बता दीजिए मुझे, अगर आपने वर्कआउट कर लिया हो. फाइनल प्रॉफिट, बिकॉज देयर वर 2 पार्ट्स ऑफ दिस क्वेश्चन. एक तो ये पूछा इन्होंने कि कौन से जॉब्स मिस आउट हो जाएंगे या एक्सक्लूड हो जाएंगे, और सेकंड क्वेश्चन उन्होंने पूछा कि व्हाट इज द टोटल फाइनल प्रॉफिट ऑब्टेन्ड. फाइनल प्रॉफिट कितना आएगा. 147 करेक्ट, बिल्कुल सही जवाब। चलिए स्टार्ट करते हैं। विल वर्क आउट विदाउट वेस्टिंग मच टाइम। काइंडली सी ऑन बोर्ड। आई एम ट्राइंग टू वर्क आउट द ग्रीडी स्ट्रैटेजी ऑन दिस, प्लीज ऑब्जर्व। I'll prepare a Gantt chart here like this. I will say this is CPU. Time starts at 0. We are dividing time into discrete intervals of 1 unit because each job take 1 unit of time to complete each job. अब ये देखिए, सबसे पहले हमारा लॉजिकल एक कंक्लूजन होगा, वो ये होगा कि मैक्सिमम डेडलाइन कितनी है। मैक्सिमम डेडलाइन जब 7 है, मैक्सिमम डेडलाइन जब 7 है, तो इसका मतलब ये है कि हमारे पास हमारे सबसेट में we cannot have more than 7 jobs. This is the first important shortcut you should apply. ये प्रॉब्लम सॉल्व करने की फर्स्ट शॉर्टकट टेक्निक ये है कि आप देखेंगे कि मैक्सिमम डेडलाइन कितनी है, 7 है। इसका ये मतलब ये है कि यू कैन नॉट हैव मोर देन 7 जॉब्स इन योर सोल्यूशन। क्यों? बिकॉज ईच जॉब टेक 1 यूनिट ऑफ टाइम। तो देयरफॉर 1 2 3 4 5 6 7 आई कैन नॉट हैव मोर देन 7 जॉब्स, दैट इज फॉर श्योर। अब हम ग्रीडी अप्रोच कर रहे हैं। ग्रीडी अप्रोच में हम बोलेंगे कि जो भी जॉब का हाईएस्ट प्रॉफिट है, व्हाटएवर बीट्स डेडलाइन, हम उसे सैक्रिफाइस नहीं कर सकते। वो हमें हमारे सोल्यूशन में पक्का होना ही चाहिए। कौन सा? वो जॉब जिसकी प्रॉफिट सबसे हाईएस्ट हो, उसकी जो भी डेडलाइन हो, हम कैन नॉट सैक्रिफाइस इट, दैट इज ग्रीडी। तो फ्रॉम अमंग ऑल दी अनसेलेक्टेड जॉब, सेलेक्ट द जॉब हैविंग द हाईएस्ट प्रॉफिट। कौन सा है? 30 इज हाईएस्ट। तो T3, तो इसकी डेडलाइन क्या है? 5। सो विल ट्राई टू शेड्यूल T3 इन इट्स मैक्सिमम पॉसिबल स्लॉट T5 फ्रॉम 0 to 5 एनी फ्री स्लॉट। ये दिस इज द मैक्सिमम स्लॉट वेयर आई कैन शेड्यूल दिस जॉब। सो देयरफॉर T3 इट कैन नॉट गेट शेड्यूल बियॉन्ड दैट। देखिए मैं कैसे कर रहा हूं, आप भी वैसे ही फॉलो कीजिए एग्जाम में। नेक्स्ट, आफ्टर 30 द नेक्स्ट हाईएस्ट इज 25 T9, डेडलाइन इज 3। इज इट अकोमोडेटेबल? हाँ, 0 to 3 कोई भी एक फ्री स्लॉट अवेलेबल हो तो आप उसे डिस्पैच कर दीजिए T9 यहां पर। फिर उसके बाद कौन सा आएगा नेक्स्ट हाईएस्ट आफ्टर 25? इट इज 23 T7। क्या ये भी अकोमोडेटेबल है? इसकी डेडलाइन है 2। 0 to 2 एनी फ्री स्लॉट? यस आई हैव, सो देयरफॉर आई कैन प्लेस T7 हियर। सो दिस इज आल्सो डन। 23 हो गया। 23 के बाद नेक्स्ट हाईएस्ट क्या है? देखिए आप, 20 है, 20 राइट। सो 20 इज T2। व्हाट इज इज डेडलाइन? डेडलाइन इज 2। एनी स्लॉट फ्री फ्रॉम 0 to 2, 0 to 2 तक इसकी डेडलाइन है, तो यहां पर हम शेड्यूल कर देंगे T2। ये भी सिलेक्ट हो गया। उसके बाद नेक्स्ट हाईएस्ट है, देखिए आप, 18 है, 18। लेट्स से T4 18, लेकिन इसकी डेडलाइन है 3। मतलब 0 to 3 मेरे पास कोई भी फ्री स्लॉट अवेलेबल नहीं है। मतलब यह है कि हम इसे सेलेक्ट नहीं कर पाएंगे। क्यों? 0 to 3 ऑलरेडी फिल्ड अप विथ हायर प्रॉफिट जॉब। इसका 18 है, ये पूरे जॉब्स के प्रॉफिट ज्यादा है 18 से। सो आई कैन नॉट सैक्रिफाइस एनी ऑफ दीज जॉब्स फॉर T4। सो T4 इज डिस्कार्डेड। ये 18 इज इट अकोमोडेटेबल? देखिए आप, 18 इज इट अकोमोडेटेबल? इट्स डेडलाइन इज 4। सो 0 to 4 यहां पर फ्री स्लॉट है, सो आई कैन शेड्यूल इट T5 हियर। तो यहां तक भी आ गए, 18 भी हो गया। नेक्स्ट उसके बाद देखिए आप 16, ये मुझे रिमूव करना है, 16 ये भी रिमूव कर देंगे। 16 इज द नेक्स्ट हाईएस्ट आफ्टर 18। तो 16 डेडलाइन इज 7। इज इट अकोमोडेटेबल? हाँ, ये भी अकोमोडेटेबल है। T8 यहां पर शेड्यूल कर सकता हूं मैं, यहां पे भी कर सकता हूं या यहां पर भी, मैक्सिमम स्लॉट में शेड्यूल कर रहा हूं मैं। 16 के बाद आ जाएगा 15 T1। इज इट ऑल्सो अकोमोडेटेबल? हाँ, ये भी अकोमोडेटेबल है, क्योंकि 7 है डेडलाइन। 0 to 7 एनी फ्री स्लॉट, यहां पर फ्री स्लॉट है, आई कैन प्लेस T1 हियर। सो देयरफॉर दिस इज ऑल्सो अकोमोडेटेबल। अब उसके बाद बच गया, देखिए आप, पूरे फिलअप हो गए। मतलब अब जो भी जॉब बचा हुआ है, डेफिनेटली वी हैव टू सैक्रिफाइस इट, बिकॉज देखिए आप, T6 इसकी डेडलाइन है 5। 0 to 5 I don't have free slot, so therefore this is discarded. So therefore the jobs that are discarded are T4 and T6, as you said very rightly. T4 and T6 as you said very rightly. So therefore this is a schedule, और इसका अगर आप सम करेंगे तो इसका प्रॉफिट आएगा 147, and that is what they ask in the question, I believe. So in the question अगर आप देखेंगे, ये है, all tasks are completed in the schedule that gives a market. T4 and T6 are excluded. This is the, what is the maximum profit? 147. That's it. That's the answer for this question. ठीक है? Before I close, I would like to ask one question on spanning tree. Let me see whether you can answer it or not. सिंपल क्वेश्चन है ऑन शॉर्टेस्ट पाथ जो हमने अभी देखा एंड स्पैनिंग ट्री बोथ. Which algorithm please alpha? Time complexity of job sequencing deadlines is order of n square. Order of n square. Not n log n. Answer this question please. Someone answer this question. Reasoning question. उसका एक फास्टर इम्प्लीमेंटेशन भी है लेकिन दैट इज नॉट फीजिबल वायबल ऑलवेज. सो ऑर्डर ऑफ एन स्क्वायर इज अ रेगुलर इम्प्लीमेंटेशन ऑफ JSD. What is the answer for this question? Reasoning questions like this, many have been asked earlier and still can be asked. ये बहुत ट्रिकी क्वेश्चन है. Many people go wrong. Many people go wrong. शॉर्टेस्ट पाथ से रिलेटेड है इसलिए मैं यहां पर लिया हूं ये प्रॉब्लम. आंसर्स आर फ्लक्चुएटिंग लाइक C, A and C, A and C, A and C में फ्लक्चुएट हो रहा आंसर. कौन? नेहा. Shifu Qadir is saying A. Prashant Prabhakar A. Logical learner is saying A. Now slowly people are converging to A. Satyam Binayak A. Okay. Spanning tree में आपने पढ़ा होगा G में भी what undirected edge weighted graph. The weights of the edges in are positive and distinct. Distinct मतलब हर edge की value different है. Distinct है. Distinct है. Consider the following statements. Minimum spanning tree of G is always unique. First statement is true or not? First statement is true or not? Definitely true. जब आपके distinct edge weights होंगे तो ये हमेशा true होगा. हमेशा true होगा. There is a property of minimum cost spanning tree. Distinct weight edges. Spanning tree is always unique. True. Second का बताइए मुझे. Second क्या है? Shortest path जो अभी हमने किया. Between any two vertices of the graph G is always unique. Is it true or false? Shortest path between any two vertices. Shortest path जो होगा, path is always unique or not is a question. Muhammad Asif is saying true. Avnesh is saying true. Not always true. Satyam B. Naik. Not always true. Correct. Not always true. Can you take a simple example to prove that? We can take a simple example to prove it that it is not always true. Like for example, vertex A, B, C, cost value 1, 2, 3. Take this. Simple example. Simple example. I want to find the shortest path from B to C. I want to find the shortest path from B to C. How many shortest paths I have? How many shortest paths? I'm not saying value paths. How many shortest paths? There are two shortest paths. Both are shortest. Both are having the least cost. BAC with a cost value 3, BC with a cost value 3. Two shortest paths. It is not unique. Paths are different. There are two paths. Simple example. Right? So therefore, be careful with such questions. Yes, this is a previous gate question, please. So therefore, only one. One only is true. Second is false. So like that, there are a few more questions like this on spanning trees and shortest path together. You practice them on same lines because time is up. We'll continue in the next class. So next class I will start with dynamic programming, wherein I will give a detailed outlook of dynamic programming, elements of dynamic programming, properties of dynamic programming, and then approaches of solving problem based on dynamic programming, and then what kind of problems are not solvable by dynamic programming. All that we will see with some case studies. Okay? Okay, take care. Good night. Thank you.